heading into our pre-processing section. Finish the EDA and we created kind of a to-do list of how we like to deal with outliers and how to deal with kind of the dimensionality reduction. And I say dimensionality reduction because we'll be creating one hot encoded features from our categories, which for every category, we're going to create more features. So we're going to create more dimensions and we want to be very conscious of that. So we're going to try and reduce the number that we're going to create in a lot of these situations and be very conscious of that. So we'll start off by bucketizing our columns, and we're going to be, again, very conscious of our outliers. So here I copied the list from up above, just a to-do list of things to do. So screen, porch, outliers, bucketize. Three S, and porch outliers right side. And going through all of these. So I'm a very nice teacher. And so I've done most of these for you. We'll do the first couple together and all the rest of them are done. The point here is though, is this now frees you up to do the experiments yourself, setting up like, oh, I wonder if Brandon only did this. Maybe if I tried this, that would work better. And you could very well be right. And so I really recommend kind of experimenting with these and trying these out. So what we'll do here to get started is we'll plot a disk plot. So we'll go SNS dot disk plot, and you can go df, and this x will be equal to screen, if I can spell screen properly, screen porch. And so there we go, got our distribution here. And what I'm noticing is that there kind of seems like there's three distinct levels. There's something up to about 200. There's 0 in this range. There's something up to about 200, and then there's kind of outliers over here. So I'm just going to make this into two buckets. I'm going to say everything under 200 is one level and everything above 200 is another level. So we're not going to have very many B's and the other level, the other category. But again, we're just trying to reduce this as much as possible. It would likely be better to use more buckets to do this, but again, being conscious of the fact that we only have 1,470 rows, we really can't create too many features. So just again, be conscious of that. So what we'll do here is we're going to go df, and then we're going to go, so I copy this time, be lazy, do professional coding, and add some copying and pasting in. And so here we'll do this again, then we'll go PD on the other side of the equal sign. So we're going to assign this to a column, and so we're going to go PD dot cut. And what we're going to do is we're going to cut the column that we want. So the feature here, screen porch. And then what we're going to do is we're going to go bins. And so if you can imagine, if you had one bin, there'd be two outside edges. So if we want two bins, there's going to be three outside edges. So I start here by putting the lowest value. I like to go, you don't want anything equal to, so it has to be, it's good to be on the one side lower. I don't think anything below is below 0 here, so just doing -1 just ensures that I think I originally put 0 here when I first tried this, and there are 0 values. So you want to do something that's lower than on the outside edge of where your bin would start. So it's good just to be safe. -1, and their lowest value will be our lowest value. The second value is going to be 200, and the max value, you can see it goes up to 500. I'm going to do just 510 to be on, again, just on the outside, just in case I'm missing and there's 505 or something like that right there to make sure they get bucketed. The next thing that we want to, the next argument that we want to do is labels, and we'll do equals. And really the names here don't matter. I mean, it can matter in situations, but in our situation, it doesn't really want to. So I'm going to call them A and B, as simple as possible. Not going to complicate anything right here. The quotation mark right there. Okay, so we'll run this and good to go. So we'll do this again for one other one. So let's try this together again. So we'll go sns.diskplot, and we're going to go df, and then x equals, and I'm just going to copy this time. Make life easy. And so we copied that, and so you can see here again we have very kind of distinct features. And I would say again, this seems like if I were to split this somewhere, I would say up to 100, and then everything over 100 can be in a different category. So because our other option with dealing with this column is to truncate our outliers to bring them in to say everything is up to 100, but nothing is above, everything above that is just equal to 100. And we'll do that clipping for other columns. This one just doesn't feel like it would work very well in terms of clipping. So this would make more sense. Again, this is very, you add a lot of bias into your choice of pre-processing, and this really will be how you affect the output of your model. So this is a very important thing, important step, but it is really, there isn't, I mean, there are certain ways that are good and bad, but whether you chose to clip this or do what I'm going to do and create categories, and then we'll create one hot features from those, is very much a personal choice and a really kind of experiment. And that's one thing that you can experiment with as well. So here we'll do pd.cut again, and this will be the ESN porch. And then we're going to do bins equal to -1, 100, and 1. And, or sorry, I should go 5 then. And then what we'll do is labels equals a list of a comma, oops, comma on the outside of that, and then as well. So we'll run our second one. And am I forgetting something here? So PD, oh, I have, what is that? A parenthesis that should be on the outside. I don't know what that's doing all the way over there. So here we go, and this should work now. Okay, perfect. Okay, and so you'll see, because I'm a very nice guy. Remember, teacher Brandon, don't forget to like the video. I did all the rest of the work for you for this one. So all these are done going forward. Again, you can experiment. I really, that would be the best thing, the most value that you could get from this project is experimenting now. Everything is set up for your experiment. So change this. See if changing this into 3 categories instead of 2 makes more sense. Okay, so bucketizes all the rest. I'm going to continue to run through my workflow, just so everything runs into the modeling section, and then going into dimensionality reduction. Okay, so same thing. I have a list of all the features that we wanted to do, and etc. So the first thing I like to do, these are features, so we're going to do df sales condition dot value underscore counts. And so we got our values here. So what we can see is I have a few values here. And place, okay. So we can see we have a few values here, and some are very small. Like truthfully, these are just almost non-existent. And the goal here again is to reduce where possible these features, and these might add value if we had more data to learn from. We really don't have enough, so it's better just to group them into another feature. So what we'll do is we'll do df dot, and then we're doing sale condition, okay, sale condition. And then what we want to do is we want to condition, I gotta spell condition right. And then what we want to do here is we're going to go df sales condition is equal to dot, or sorry, not equal to, dot replace. And so what do we want to replace? Well, we want to replace a list of this right here. So let's copy and paste this. So family, and these are all capital, so I need to change these. So family, and so this is a capital F, and capital A, quotations, comma, and then quotations, edge land. L is capital as well. So we're going to replace those with abnormal. So all of those will be, whenever it finds something in that list, we're going to replace it all abnormal. We're going to replace it with the word abnormal, and thereby reducing it. So we're also going to call here, we're going to go in place equals true. And so one of the things here, because we have our test set, we also want to make sure we're doing the same things to our test set. So we're going to unprocess this as well here, test, and this is happening to our test, our underscore test data set. So run this now and perfect, good to go. And so going on to the next one as well. And just thinking of one thing that I forgot to do up here is we needed to, in the features that we did, bad teacher, and I forgot to do, what we need to do is we need to run and do this only on, or do this on the test set as well. So let's rerun these few cells right here. And just remember that you need to do these as well. So just comment this out and run this cell. Okay. And then the next one that we did as well. So copy this and do test right here. So really important to remember to do, we have to do this on both the pre-processing on both of our features, and really pre-processing in my eyes is a lot like really the magic that you put into your model, and this is really where the magic is going to happen. And so you see all the other ones, it's already done, test is done for both of them, and keep going through all of that. And anyways,